Okay, so we want to name this compound, and the first thing that I'm going to start with is the chiral center, which is right here. And let's go ahead and draw in the implied hydrogen so we don't forget about it. And it must be back. So now look at the 4 atoms directly attached to the chiral center. We have the hydrogen, the isopropyl carbon, and this carbon. So the 3 carbon are tied, but hydrogen gets a lower priority than those, so we'll make hydrogen 4. Now let's look at what each of these carbons are attached to. The one on the top is attached to 2 carbons and a hydrogen. The one on the bottom right is attached to 1 carbon and 2 hydrogen. And the one on the bottom left is attached to 1 carbon and 2 hydrogen. So based on that, we can go ahead and give priority 1 to the group on the top because 2 carbons beat 1 carbon. The 2 on the bottom are tied, so we need to move out 1 space in each direction. So I'm going to move out to here and here and do a comparison. So now on the right side, this carbon, it's bonded backwards to the chiral center. We're not going to label that, but this is also bonded to 1, 2, 3 carbons. On the left-hand side, this carbon is bonded to 2 carbons and a hydrogen. So 3 carbons beat 2. So this will be priority 2. This will be priority 3. Our hydrogen, priority 4, is already in the back. So we're ready to draw in our curved arrow. We go from 1 to 2 to 3. That goes around to the right. So this is the R configuration. Now let's name this. Let's start by finding our longest carbon chain. And that is this chain right here. We'll number it. And we're going to start from the left because if we start from the right, 1, 2, 3 is where we run into our first substituents. From the left, we run into our first substituent at 2. So that's better. We'll do 1, 2, 3, 4, 5, 6, 7, and 8. Then we have a methyl at 2, a methyl at 6, another methyl at 6. And we also have an isopropyl at 4. I comes first alphabetically, so I'm going to do the isopropyl first. Then we have the 3 methyl groups. And I'll put the number for each. 2, 6, 6, trimethyl. We're alphabetizing by the I and the M. And then our parent chain is 8 carbons, so that's octane. We can't forget about the configuration at our chiral center, which is R. So I'm going to put R in front of the name, or you could put 4R to designate its location, but it's not really necessary to put the number since there's just one chiral center.